Hello, good morning all. Okay, as I promised, today we will discuss these two questions. Basically, the questions given to you is come from the way how they will question you in exam. So normally this is the previous year paper 3 questions. One will be come from your plotting graph, skill of plotting graph. Another one, they will ask you interpret from the graph given. Okay, so in this case you need to learn to extract informations. Okay, to extract information. So let's read the questions. Okay, now a student carries out an experiment to investigate the relationship between the mass of slotted weight, the mass of slotted weight. So this is very important. Okay, mass of slotted weight. Okay, right. Okay, and then they are talking about the period of oscillation. Okay, period of oscillation. So definitely you are giving two information here. Okay, one is mass, another one is period of oscillation. So it's mass and then period of oscillation T. Okay, all right. So we don't know yet what is your responding variable and manipulated variable. Roughly you should understand that your period of oscillation will be your RV and your mass should be your MV. Okay, so you already have this information. Next. Okay, next let's check the diagram. So you have slotted weight, you have spring. Okay, definitely you will need, since they're asking about the period of oscillation, you will be asking about the stopwatch. Okay, so next, what are the information? Again, a slotted weight of 100 gram is hung on the spring and displaced to let it oscillate vertically for 10 complete oscillation. So the time taken, okay, for the time taken is basically the 10. Okay, 10 complete oscillation. Okay, 10 complete oscillation, the time taken. So you see, the time taken for 10 complete oscillation T is measured using a stopwatch shown in your diagram. So what is T and what is T? Okay, so your T is the time taken for 10 complete oscillation. Your period will be your time taken by the 10 complete oscillation divided by 10. Okay, so that is the information that given here. The procedure is repeated with the mass of the slotted weight. Okay, you have repetition of 5 different masses, and then corresponding reading for 10 complete oscillation T is shown in diagram 1.3, 1.4, 1.5 and 1.6. Alright, now we go for the next question. So you only given informations, right? You only given informations, but you don't know what is the question, right? So we go to the next one first, because they didn't give you, you haven't read the question. So we go here. Okay, for the experiment described in page 2, page 2 previously, identify the manipulated variable. So what is your manipulated variable? Okay, yes. Slotted, the mass of slotted weight, that is your M. Okay, what is your responding variable? the period of complete oscillation. Where I can get this answer? Okay, look at here. You see? You see? Period of oscillation, mass of slotted weight. So you just rewrite them into the question. Okay, what would be the fixed variable? Okay, what would be the fixed variable? What are the things that you don't change? Okay, definitely you may say there is a lot of answers here, but you only give one. Okay, only give one. So they might be the length of spring, okay, the stiffness of spring, or the diameter of the spring, okay, or you don't give type of spring and so on. Maybe the spring constant, okay. So here the fixed variable must be something that you can measure. Okay, you can measure. Don't give something that you cannot measure. For physics, we cannot take them into account. Clear or not? Okay, so that's how you can get 1 mark, 1 mark, and 1 mark. So even though you have more answers here, you only need to write one answer. Okay, then next one. Based on diagram 1.2, 1.3, 1.4, 1.5 and 1.6 in page 3 and page 4, record the values for t in the space provided. Okay, then you see 2 marks. Then determine the values of period t using the formula. Even though they didn't give you the informations about this previously, but you, with your logic, okay, your richness in your thinking, you can already detect what is t capital, what is t small, right? So then you need to write down all the answers here, and then tabulate your results for m, t capital, t square, and in the space below. So this one later we do. First we need to do 1, 2. So here you have the skill. You must have the skill to read the analog stopwatch. Okay, analog stopwatch. So meaning to be your t is the time taken divided by 10 complete oscillations. So you write this over here. Okay, and then you check here. For the first 100 gram, you see the small needle in the small circle. It's in the 0 place, right? So that means it just started. Okay, so you can mention, see clearly. Okay, see clearly. So this is 1, 2, 3, 4, and then you look at here. Okay, you look at here. So 1, 2, 3, 4, meaning to be 1, 2, 3, 4, then 5. So this length is divided with 5 division, meaning to be 2 minus 3. So 1 divided by 5. So the small one will be 0.2. So meaning to be, look at here. So the first one. So this one is 0.2. So 4.2. Clear? Okay, so here should be your 4.2 second. Unit must be there since the sensitivity is only one place. Okay, then second one. Okay, second one, check here. Alright, sorry. Okay, second one, check here. It's 5.2 second. Okay, then see 5, 6. So 6. Don't write 6 only because just now the other reading all 1 decimal places. So 6.0 second. And then you see here 6. So look at it, 6.2, 6.4, 6.2, 6.4, 6.6. So 6.6 second. Then here will be here 5, here 6, here 7, 7.2. So 7.2 second. So before you finalize your answer, you check all the decimal places, right? If 1 decimal places, meaning to be everything must be 1 decimal places. This is what we call consistency of your data. So by using your calculator, what do? You don't have to do the calculator lah. So looking at the answer, you already can answer already. So just move your decimal point to 1 towards your left. That is divide by 10. So 0.42 second. Okay. This one 0.52 second. This one 0.60 second. You see, I don't forget my 0. Okay, I don't forget my 0. This one 6.66 second. Okay, this one is 0.72 second. Now, you see all the 5 answers are correct. Okay, you get T all correct, you get 2 marks. If all the 3 correct, you get 2 marks. Only from reading and recording your data, you already get 4 marks here. Okay, and then next. Okay, tabulate your results for MT. What is given here? You already given. Okay, so you draw. Use pencil to draw your table. Okay, so M gram, T second, capital T second, T square, definitely S also square. So you have to see your 3 marks. So rewrite everything. Okay. Alright. So here they give you 0. It's given already, Okay. 200, 250, 300. Okay. Now, why I put 0 here? Okay, look back at your question. Did they mention the 0? Yes. So, use them. Your T for 2, 5, 2, 6, 0, 6, 6, 0.72. Okay, see, all of them are having the same decimal places. All of them are having the same decimal places, so remember them. So next, 0.42, 0.52, 0.60, 0.66, 0.72. Check the decimal places and then use your calculator to square root them. The possible square root here is 3 to 4. If you give more than 3, it will be more accurate. So far, please check your answer. 0.1764, 0.2704, 0.36. Don't stop at 36. You must make sure it is same decimal places with the rest of the data. 0.4356, 0.5184. For this one, okay, so we don't give mark over here, no mark. Okay, no mark, no mark. Okay, here we will check the decimal places. 1 decimal places. Here 2 decimal places. Here 2 to 4 decimal places. Okay, and then we will check we will check this one, we will check this one, we will check this one. Okay or not? Okay, this one and this one. So here 1 mark. So here 1 mark. Okay, the decimal places over here 1 mark. This one 1 mark. So total 3 marks. Okay. Then on the graph paper on page 6, that means next one, you draw a graph t square against m. So look at this and look at this. So you need to know which data you need to present. So looking at them, so this will be y, this will be x. Okay, so getting back to the data. Okay, having data something like this. Alright, so don't draw two inside your data. So what you need to do, you draw the line over here. Okay, use your pencil and ruler. Okay, right, so here is t square, s square, here is your m, g, origin. Okay, now how to do the data? Okay, so we have 6 starting from 1, 2, 3, 4, 5. Okay, so 50, 100, 150, 200, 250. So not enough. So you make it smaller. So this one should be 50, 100, 150, 200, 250, 300. Okay, then how about your T2? So to see the T2, you need to look at the data. Which one is the highest data? Definitely this is your highest data. So you cannot make it 0.5, but you can make it 0.6, right? So the maximum, you round it off first to get the correct scale. So you look at the highest data, then round it off to the bigger number near to it. Okay, so if 0.5, make it 0.6. Okay, when you are talking about 0.6, so how many boxes that you have? 1 2 3 4 5 6 7 8 9 10 11 12. So you have 0.6 and you have 12 boxes, so you can easily can mix and match it, right? So 0.6, you have 12, so that means 0.6 divide by 12, you might get about 2 lah. Okay, so 0.1, 0.2, 0.3, 0.4, 0.5, then 0.6. So this is to completely utilize your graph paper. Then, okay, what you can say, okay, what you can say. So look at the first data. Okay, look at the first data. So in order to get accurate answer, okay, right, okay, accurate answer, you need to know the smallest beta. Okay, 0.1 divide by, so here you have 20. So what you get your answer? Okay, wait, I get the calculator. Alright, so 0.1 divide by 20, so you get one small beta is 0.005. Okay, 0.005. So what you can do here is you get the first data. Okay, your first data is 0.1764 divided by 0.005. So what you get? 35.28. 35.28. So 10, 20, 30, 35 in the middle. Okay, so that's how you need to do the rest. So the next data is 0.2704 divided by 0.005. So 54 point came. So you see 10, 20, 30, 40, 50, 54 roughly here. Okay, next one is 0.3600 divided by 0.005. So 72. 10, 20, 30, 40, 50, 60, 70, 72 accurately. Okay. Oh, sorry, it's starting from 50, 100, right? So I cannot use this. Okay. So first one is 35. Okay, 35. Twenty, 30, 35 over here. Okay. Oh, 35 is here. 35. Okay. Then what was again? over here. 35, 54. Okay, 54 here. Okay, use your cross, right? Then 72, 72, 60, 70, 72. Accurately, 72. Then what else? 0.4356 divide by 0.005. So 87.12. So 10, 20, 30. 10, 20, 30, 40, 50, 60, 70, 80, 87. 80, 87. Nah. 87.12. So almost here. Okay. Alright. So the last one. What is the answer? 0.5184. So 0.5184 divide by 0.005. Okay. 103. Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 103, 68. So 103 in between. 100, 103. Okay, over here. So using your ruler, you can get a straight line. Okay, you got the correct answer. See, correct or not? It's going through a straight line. Okay, so see, you have, what are the things that you have? Number one, okay, you have title here. You already given title, so no mark for the title. Label, you have label. Okay, you have label, right. You have unit, right. You have uniform scale, right. You have origin, right. You plotted the right points, correct points, right. Okay, baseline, correct. Y-intercept, correct. Okay, use 50% of the graph paper, more than 50% of graph paper, right. So if you get all, then you get 5 marks. Okay, can? Okay, then see the graph line is going through the 0, right? Okay, so based on the graph on page 6, so state the relationship between the t square and m. Okay, so t square is directly proportional to m. So 1 mark. Okay, so this one must remember the correct keyword. Okay, based on the shape. Clear? Okay, next question, question number 2. Okay, now Question number 2. You see question number 2. Okay. A student carries out the experiment to investigate the relationship. Okay, the relationship between the force and the acceleration. Okay, force and the acceleration. So between the force and the acceleration. So now y, then your f is at x. Okay, so acceleration here already given. That is the information, right? So based on the graph above, what happened to f when a decreases? What happened to the f when a decreases? But the graph is showing a is increases and y is increases, right? A is increases and y is increases. A is increases and f is increases. F is increases and then a is increases. So what you can say? They are directly proportional. So definitely your answer will be decreases. Okay, so 1 mark here. Okay, determine the value of f when a is 24 meter per second. A is 24 meter per second. So 24, A is 24 meter per second. So you see 24 here. Is your answer? Okay, if you notice, it is not reaching, right? So what you need to do? Need to use your ruler to extrapolate. Okay, and then what you are going to do? You are going to draw the dotted line. Okay, 24, 24, use dotted line. Okay, then what you need to do? You get the exact place. Clear? So what is the answer? So your F is 6.5, 6.5, 6.6, 6.7, 6.7 Newton. Okay, 6.7 Newton. So you have to show in your graph. Okay, so then you write down here. So 3 marks, meaning to be first mark you are showing in the graph. So 1 mark. Okay, you write down the answer 6.7, then Newton. Okay, so 3 marks. Here 2 marks lah. Sorry, here 1 mark. Okay, here 1 mark. 1 mark. Where you can get the another mark? Here 1 mark. You extrapolate. So 3 marks. Then second question. Calculate the graph. Calculate the gradient of the gradient. Okay. Okay. The gradient of the graph. Show on the graph paper, how do you calculate your K? So, in order to get this, you must use something that you already have, right? So, you can use your answer just now, and then you just use okay, you already have the previous one, and then remember to put this small right angle, okay, and then you find out what is the calculation. So here is 24, here is 0, okay, then here is 6.7, here is 0. So you can straight away bring this over here, because your gradient K is your y delta and your x delta. So how do you get this? Your y delta is just now is 24, 8. Okay, here is 24. Sudah hilang pula. Okay, here is 24, here is 0, so this is your delta y, this is your delta x. So what you need to do here, so 24 divided by 0, 6.7 divided by 0. So what will be your answer? Okay, here remember what is the unit here? Check back in your graph. Unit meter per second, Newton. Meter per second, Newton. Okay, so this one will go up. So when you do calculation, you will get 3.582. Do not round off. Okay, do not round off. So meter per second, Newton per second. Okay, meter per second, Newton per second. So here you rewrite 3.582 meter per second, Newton per second. Okay, so you get 1 mark over here, 1 mark over here, and then your right angle triangle 1 mark. So 3 marks. Okay, clear? So that is how you get this answer. Now we move on to the next question. Okay, by using the formula F equals to MA, okay, and the value obtained in B1, so which one is your B1? Okay, so you already have it. Calculate A, so this is your F. Okay, F is equals to MA. Okay, F is equals to MA. So, how do you use this one? So, you know this is your A, this is your F, this is your 0. So, you get this, and this is your K. Correct or not? So, how do you going to relate this? This is your Y is equals to MX plus C. So, here the C is 0. Correct or not? Okay, your C is 0, so your A is equivalent to your K F plus 0. Correct or not? So, meaning to be, you are going to find out your A. Okay, so meaning to be, when F is equivalent to 30 Newton. Okay, so you are going to see your F is 30 Newton. Your K is, your K is 3.582 meter per second per Newton. So what is your A? So your A is, okay, basically you see, you see F is equal to MA. Your KA, you are going to use this. Your K is 3.582, then 30. So you calculate your answer, 107.46 meter per second. So this is your answer. Okay, clear or not? Okay. In this case, your M is not given, right? In this case, yeah. So you ignore that. All right. So that is how we are going to use this. Okay. Next, state two precautions that can be taken to improve the accuracy of the reading in the experiment. So the purpose is to improve the accuracy of the reading, right? Accuracy of the reading. So there are two. When you're answering this question, you must mention the action and then you must mention what is the reason. Action and reason. So the first thing, okay, the eyes must be perpendicular to the scale of what you use here, force, right? So you use spring. Okay, scale of spring balance. Okay, spring balance to avoid parallax error. Okay, so your reason. Okay, your reason. So this is your action, this is your reason. Number 2. Okay, what else you can do? You must repeat the experiment lah. Okay. Repeat the experiment for another 2 more times, and take the average reading. Okay, so this is another mark. So 1 mark, 2 marks. So clear? That is how you are going to answer this question. Okay, clear or not? Okay, that's all for today. So make sure you answer this and then you upload in your Google Classroom. That's all for today. Thank you. Bye bye. And happy Chap Gome ha.